So first thing that we need to know for salt analysis is that what exactly is salt. So salt, as we know, it's made of a cation and an anion. So if I want to know what salt we are talking about, I need to know the identity of the cation and the anion. So how we do it is that we try to look for something that only that cation can do. So we try to find a way to identify the cation based on something that only that one can do. One way of doing that is to look at the precipitates that they form. What exactly is a precipitate? It's a solid that comes out of a solution. And why is that? It is because when two things react, if they form insoluble salt, that salt will obviously be a precipitate. So for example, if I had silver ions and chloride ions and they're moving around in a liquid, but if they react together, they will make AgCl, which is solid. So it's insoluble in water. What that would mean is that I will start seeing this solid come out from ions to solid. And if I can do that with the cation that I'm interested in or with the anion that I'm interested in, then I will know for sure that the other thing is that. So for example, if I wanted to check if I had chloride ions, then I will just add silver ion and I'll hope that I get white precipitate because that's what silver chloride is. So if chloride is there, I'll get white precipitate, and that's an indication that, yeah, you had chloride because you added silver. So that's how we do it. What we used to do that for cations is that we know most hydroxides are insoluble. So we try to make hydroxides from whatever cation we have. So we react them with something that will make their hydroxide, and then we can identify them that, all right, this is that cation and this is that cation. So hydroxide, the best way of doing that is to add any snap hydroxide. Why snap? Because, for example, if I were to add sodium hydroxide in there, then sodium will react with something and hydroxide will react with something. But no matter what sodium reacts with, it will neither give us a color nor a precipitate. Why? Because sodium is not a transition metal, and sodium, secondly, is always soluble. Any salt of sodium is soluble because it's snap. So this way we are able to only get the hydroxide solid. And if we do get a solid, we know that we have the cation. So that's the way. We take the cation that we're looking for, we try to make it hydroxide, and if the hydroxide is there and we can identify the hydroxide, then we know what cation we have at hand. Now, there are two steps to this. The first thing that we do is to check the color test. So that's the first thing. So I'm talking about cations for now. So we do the color test. What does color test mean? It means that you make hydroxide of the cation. So we are going to do color test of whatever hydroxide we are going to make. So what do? We add sodium hydroxide to whatever ion we have. Now there are three ways we can see what the result would be. So three possibilities exist. The first possibility is that instead of making a precipitate, that thing will simply make a gas. And the way that happens is that basically you have ammonium ion, and if there is ammonium will react and make ammonium hydroxide, right? Ammonium hydroxide is going to further break down and form ammonia gas and water. So that is what we see. So let me share this with you. Yeah. So this is how it goes. For the color test, we add a few drops of sodium hydroxide. So we just need to know, does it form a cation? Does it form a hydroxide which is soluble or insoluble? What happens? So if you have ammonium will make ammonium hydroxide, which breaks down, forms ammonia and water. Water stays back, ammonia goes out. And we know once we check ammonia gas that, all right, I have ammonia. Now, how do we check ammonia gas? That's basically gas tests. So to check for ammonia, which is the only basic gas in your syllabus, you take a damp red litmus paper and it should turn blue if there is ammonia. So what are you going to see? You're going to see bubbles. So Adding sodium hydroxide few drops, if you see bubbles, that means there is most likely ammonia gas coming out. You check for ammonia gas, and if it is confirmed, then you know that, all right, I had ammonium hydroxide, and that is basically ammonium ion. Now, what you can also get is white precipitate. White because there is no traditional or typical transition metal ion present. So this precipitate is basically the hydroxide. So there are three options in our syllabus. You can either get calcium hydroxide, aluminum hydroxide, or zinc hydroxide. They're all white. They're all insoluble. And that's what we see. We see hydroxides which are insoluble as white colored. Now, of course, right now we don't have a way of differentiating that which one do I have? Do I have calcium? Do I have aluminum or zinc? We don't know. But we do know that we have narrowed down our options to these three. Now, what if we have a colored precipitate? Instead of getting a white precipitate, we see a colored. That means that we have transition metal ion, because transition metals are the ones that give us colored precipitates. Which one? So we have the three basic, the primary colors, red, green, and blue. So for red, we'll have iron 3, for blue, we'll have copper 2, and for green, we'll have iron 3 and copper 3. The whole point of doing this is to make hydroxide, which is insoluble, and based on the color of hydroxide, we are able to identify what cation we have. So this was color test. The second test that we have to do is solubility test. So after you know the color, you want to know if in the excess of hydroxide, will it be soluble or insoluble? So that's the thing. So what we do is we take the hydroxides. For example, if you're working with sodium hydroxide, you take that in excess. So by excess, I mean that, for example, if you're doing it in test tube, you fill the test tube to 2/3 or more. So add it in excess. Now, obviously, it's a solubility test. Either the thing will dissolve or it will not dissolve. If it is dissolved, then we have only three options: zinc, aluminium, and chromium 3. These are the ions that dissolve. So how does that help? So in the white precipitate category, we had calcium, zinc, and aluminium. But now that zinc and aluminium have dissolved, we know that calcium is the one that does not dissolve. Similarly, in the green category, the green color, we had two options. We have chromium 3 and we had iron 2. But now, after adding it in excess, we can see that chromium 3 has dissolved. So the one that did not dissolve is definitely iron 2. So based on this, we have been able to identify which one of these 8 ions we have at hand. Of course, we still do not know which one is zinc and which one is aluminium. That is one thing that we are not sure as yet. So no problem. We will make another hydroxide. Remember, it's always hydroxide that we're trying to make because they are mostly insoluble. So we'll add another SNAP hydroxide, and that is ammonium hydroxide. Remember, SNAP means sodium nitrate, ammonium, and potassium. We have already done it with sodium. Let's see what happens if we do it with an ammonium. So method remains the same. We do the color test with a few drops, and then we do the solubility test with that thing in excess. So that's exactly what we do. So with ammonium hydroxide, we add a few drops of it, and there are 3 possible cases. We can either get no reaction. Why? Because number one, ammonium hydroxide will not react with ammonium ion that's already present there. And with calcium hydroxide, even if it reacts, it's possible that calcium will be soluble. You will not see a precipitate. There is no visible change. Now, with white precipitate, you have 3 categories. Why? Because calcium is already in the no reaction category. So with white precipitate, aluminium and zinc are going to form white precipitate, and we're going to see that that precipitate simply comes out of the solution. And for the other 3, if it is colored, then we know it's transition metal, and the 3 primary colors, red, blue, and green, we already know what the color entails. So red is iron 3, blue is copper 2, green is iron 2, and chromium 3. So these are the 3 primary colors and the ions associated with that. Now, just like the previous, we add this in excess to see if the precipitate dissolves or not. So when we do that, these 2 dissolve and the rest do not. So zinc 2 dissolves, and this is the key to understanding whether you have aluminium or zinc, because now, because you have zinc in there and aluminium, Both of them are white, but zinc is dissolving, aluminum is not. So with ammonium hydroxide, we're able to categorize all the three into different stuff. We can see with calcium, it does not react. With aluminum, it gives white precipitate that doesn't dissolve. With zinc, it gives white precipitate that does dissolve. Similarly, for copper 2, there's this extra information that you know. Already we have identified what copper 2 is, that it's blue and doesn't dissolve in sodium hydroxide. It gives a blue color with ammonium hydroxide, but just so you know, it also makes a dark blue solution. It dissolves when it reacts with excess ammonium hydroxide. And the rest of them will not dissolve. So based on this, we can see which ion do we have. Remember, these colors, precipitates, white precipitate, all of that is for the hydroxide. So when I say I know zinc, I'm basically saying I have seen zinc hydroxide. And based on that, I can infer that I have zinc. So that's the thing. So these are the cations. So we have 8 cations. The important points to remember. Number 1, transition metals always give colored precipitate. Iron, copper, green, chromium and iron 2 are the ones in our syllabus. Zinc is not a transition metal ion. Now, aluminium and chromium are the ones that are dissolving in sodium hydroxide, and copper is the one that dissolves in ammonium hydroxide. While zinc ion dissolves in both of them. Why? Because zinc hydroxide dissolves in both of them. And calcium and ammonium ion do not react with aqueous ammonia. So these are the 4 points that you need to remember. So every time you see a question on this, just know that you have to do the color test and the solubility test. And based on those tests, you can easily identify what cations you have. Okay. Now let's move on to anions. Anion is pretty simple. Just remember that the anions that have 8 in them, they give gas, and anions that have ide in them, they give precipitate. So that's a way of memorizing. So carbonate, nitrate, they're the ones that are going to give us gas, and chloride, bromide, iodide, sulfides, sulfate, these are the ones that are going to give us precipitate. Of course, sulfate is there. Now, we also add nitric acid to all of them just to make sure that carbonates, if there are any, they are destroyed and they give carbon dioxide. So nitric acid is added to all of them except nitrate. Why? Because if you are testing for nitrate, you can't introduce nitrate yourself. So let's just get that out of the way. So let's suppose I want to check for nitrate. So I will take sodium hydroxide. This is the same sodium hydroxide that we used for cation test. So we'll take sodium hydroxide, but this time we are going to add aluminum foil and we're going to heat it up. If you don't heat it up and you get ammonia, that means you have ammonium ion, as we have seen before. But if you do heat it up with aluminum foil and you still get ammonium ion, you still get ammonia gas, that shows that you have nitrate ion. This is a misprint here. This is supposed to show that we have nitrate ion, not ammonium ion. Similarly, if you take nitric acid and you add it, it destroys the carbonate. Why? Because nitric acid gives hydrogen ions. They react with carbonate ion to make carbonic acid, which breaks down to give carbon dioxide and water. So that's what we see. If you get carbon dioxide, which you can test by passing through lime water, it makes it milky. Then you know that you have carbonate ion. Now, for the others, you add something that will not react with nitric acid because you have already added nitric acid. So we add a nitrate. We add silver nitrate, we add barium nitrate. Now that silver nitrate, remember that halide ions are insoluble for silver. So that's exactly what we see. Halides, if you want to test for them, you add silver there. So with silver chloride, we are going to get white precipitate. With silver iodide, we are going to get yellow precipitate. But the interesting thing is that bromide, which is in the middle of these two, it gives us a off-white precipitate, which is like a color between white and yellow. So chloride, bromide, and iodide that way, although bromide is not tested in the exam. Second thing is, if you want to check for sulfate or sulfite, which we call SOX. So For sulfate or sulfide, you are also going to add some nitrate because we can't have another ion because we have already added acid. So nitric acid we have already added. We add barium nitrate. Why barium? Because barium sulfate is white precipitate. Barium sulfide is white precipitate. Remember, barium gives us insoluble salts for sulfate. So that's what we get. With sulfate, if sulfate is there and we have added barium ion, it's going to form barium sulfate, solid. And for barium sulfide, the same. But the difference is that if you follow this with HCl, then barium sulfide will dissolve, but barium sulfate will not dissolve. So that's an important point to note about sulfate and sulfite. Sulfite is not in our, is a new addition to our syllabus. So these 6 anions are the ones that we test. So once you know what anion you have, what cation you have, you can easily identify what salt you have. And that finishes the chapter for us.